Friends, this is Jitesh and you are watching my channel where I am teaching you data structure and algorithm. In my past lectures, I tell you what is data structure types, what is algorithm, analysis of algorithm, and then I teach you recursion, backtracking. So recursion, importance of recursion, and also I tell you one program and recursion versus iteration. So some sort of things I tell you about the backtracking. And also I promise you I will tell you what is linked list, operation on linked list, array versus linked list. So let's start today's topic. This is Jitesh. So what is arrays? So first of all, starting if I tell you what is linked list, before that we need to take a look what is arrays. So arrays, one memory block is allocated for the entire array that hold the element of array. I will tell you step by step and graphical representation also. So keep stay tuned with us. Every single thing you can understand easily. So the element can access constant by using the index of a particular element as the subscript. What is the advantage of array using the array? Simple and easy to use. Faster access of element means constant access. What is the disadvantage of array? Waste memory space for indices in array that are empty. Fixed size, one block allocation, complex position based insertion. Let me tell you how it is a graphical representation. So suppose this is the, let's start. Okay, suppose this is your array and suppose this is your memory. Inside memory we have another memory allocation which is represented by the such continuous memory allocation, where this is the block system and it is positioning with the index. So this is the memory where actual data is stored. So this is the memory where actual data is stored. This is the data. Okay, and this is in indexes. So this is 0 index, and this is 1 index, this is 2 index. So 0, 1, 2, 3, 4 up to n. So this is the continuous memory allocation that is represented as a array. And previously I tell you this is the fixed size. So definitely the n, I am telling you 0, 1, 2, 3. And suppose we take n is equal to 10. So it means it up to the 10 blocks. And 10 blocks should be in one continuous allocation inside the your whole memory. Okay, so faster access definitely is faster because this is the index base. So faster access means suppose you want to take the element of the nth, means suppose third element, you just pick the nth element. Waste memory means suppose you have a size of the 10 but you have a data, you have only four objects which you want to store. So up last six object, it is a waste, its memory is waste because memory is initialized initially, so that is the memory waste. And complex positioning based system means, complex positioning means suppose we want to insert one element within middle of any block. Suppose you want to insert index is equal to 2, but to have already data. So what you want to do? Up to the last element, you need to shift one by one. So 1, 2 is placed to the 3, 3 placed to the 4, and this is the shifting. So shifting takes time. That is called the complex positioning based insertion. Okay, what is the dynamic array? Let's take the advanced level of the array, that is the dynamic array. And dynamic array is also called the growable array, resizable array, and array list. Variable size data structure allow element added or removed. Dynamic array shows, suppose n is equal to 5. We want to insert of the 5 element, but in the real time we have a more element up to the 10. So what we want to do? We want to increase this array size. So this is called the dynamic array. The dynamic array has one property, it increase size on the runtime. Means if you initialize n is equal to 5, dynamic array it will increase your size on the basis of your algorithm. Algorithm may be multiplied by 2, may be multiplied by 1 by 1, one may be multiplied by 10. So depends on your requirement, right? So here I am telling you, in general case its algorithm is multiplied by 2. Suppose initial value is 10, then multiplied by 2 into 2 means its load factor is 2. Okay, so this is called the dynamic array. So what is linked list? uh, Linked list is data structure used for storing collections of data. A linked list has the following property. What is the property? Successive element that are connected by pointers. Last element point to null. Can grow and shrink size during the execution of a program. Can be made just long as required until system memory exhausts. Does not waste memory space but takes some extra space memory pointers. It allocates memory at its growth. So what is this? This is the properties I am telling you. Let's simulate this into pictorial form. So I have already do some sort of the memory allocation. So suppose this is your memory and this is your blocks. This is your memory and this is your blocks, where blocks have a two segment. The first segment is actual data and second segment is reference of another block. Suppose this is the block and its reference value is x, means its memory allocation value is x. So it holds the x value into the next segment. So this is the two this is the two part. First is data, second is the reference, and reference hold to the another block of your memory. So same thing will apply to the next block also, and the last element, its last element is reference value is null. Okay, so you can relate is Indian railway, and Indian railways have a bogies, and bogies have a hook which holds another bogie, right? So this is the simplest example I am telling you, the linked list example. This is the railway system, and last bogie you always see the x. X means null, there is no bogie inserted, and initial value is head. Head means engine. So this is the linked list structure. What is the operation we can perform over the linked list? We can insert, we can delete full list and count, find nth node, and what is your custom operation you can perform over the linked list. So stay tuned with us for my next lecture. Thank you for watching.